Hi. Um, Hello, everyone. This is the cis256 Python level 2, and we'll continue talk about stacks and queues. And in this section, we can talk about queue. So what is a queue? Well, there's a lot of queues in your daily life. Let's just, for example, when you go to McDonald's, right, and to order your food, or you go to a library to check out a book, or you go to a bank, there is a line. And in British English, I think the line is called a queue. So basically, queue is a line, and the first person get in the line will be the first person to be served. So it's also called first in, first out, or FIFO. Okay, so of course, given that definition, there will be some simple operations just like a stack, right? So remember, a stack is first in, last out, right? Because you have stack of plates on top of each other. So the last plates being put on top of it will be the first to be moved, popped out. For the queue, you in-queue the object from the back and dequeue it from the front. So the first that gets in the queue will be the first served, or first in, first out, which is also short for FIFO. Right. So that's the difference between a stack and a queue. Okay, so there's a lot of application of queue in computer science and other applications. For example, on the keyboard, when you're typing something, right, not all the characters are immediately shown in a process by the CPU, because there will be, the CPU is very fast and you're typing, although some of you are pretty fast typer, is still slow compared to the CPU cycle. So a lot of things are waiting to be processed. There's a buffer called keyboard buffer that stores the keys, right? Because the CPU may be tied up with something else, and your interrupt may not be handled immediately, and you need a queue to store your typing. Okay, and then print queue is a very common one, right? So whenever you have a network printer shared by many computers, whenever you have a job, your job is being printed as first in, first out manner. Okay. So any communications of data between the two entities that usually work at different speeds, so you have to wait, and you probably need a queue to store the information between two entities, so you don't have a loss of information. So the abstract data type for the queue, of course, is the object itself, and an in-queue with item, and dequeue is removed from the front of queue, and also a function to check if the queue is empty and get the size of queue. So that's a pretty standard application. Now here is a table for some common queue operation. Again, you can use a Python list to simulate the queue. Okay, the Python list, first of all, empty list can represent an empty queue. And if you include 4, it just append, let's say append 4 at the back of list. Right? If you include a dog, well, in this case, you append to the left of the list. So you can use insert 0, right? You can use insert 0 to simulate insert to the left, and in queue, that's in queue, right? Size simply count the number of items in the list, and then you can dequeue. Dequeue is basically pop one from the back of the queue. So you can use pop method from the list method. Okay, so this, let me see, in queue is like insert 0 an item, right? And the pop dequeue is basically pop. Okay. Of course, this is not return value. This is a operation. All right. So that's Q. Now, what is Q used for? Right? Before I do that, let me just show you some code about the Q. Here is the class Q, and again, you can see we use internally use a list to represent a Q. So if you enqueue it, it just insert 0 colon, comma item DQ, you just pop it, right? Right. So that's the Q. And there is something called the deck. Deck is basically a double-ended Q, which you can insert either in the front and pop at the back, or vice versa. You can insert the back and pop the front. So you can insert and pop in both directions. That's a deck, double-ended Q. That's the API for the deck. You can add the front, add the rear, remove front, remove rear in size. Right? Now, in reality, Python has a collections module which has a deck implemented already. So I can encourage you to just use the internal one in Python. For this deck, the syntax is a little bit different. So if you want to, so say if we have a, let's say you have a queue, from left to the right. So the front is, let's say, yeah, the front is basically this direction, right? This front, and this is rear. Okay, so when you are add things in front, you can just append stuff, right? If you add to the rear, you want to do append left. Append left is append to the left of the queue. Okay, if you want to remove one, like remove front, then you can just do a pop. Pop is remove front, and if you want to remove from the rear, you can do pop left, right? So append pop left or append left pop is the two pairs for the enqueue and dequeue in the deck. All right, so this is how it works. So if I run this, you can see I do have a deck instead of 42, 3, and 100. And if you pop one, you get rid of 100, you get 42, 3. And if I do pop left, I get rid of 42, I have a 3 left. Okay, so that's the deck. Now, whenever you use a queue, you can just use deck, right? Deck is more flexible, versatile. So just use a deck in terms of the queue implementation, and you don't need anything else. Okay, let's go back to the slides. So what's the use of the queue? Well, just like a stack should be used as a reverse list, right? And the parenthesis checker, balanced parenthesis, remember, and calculator. Reverse polish notation and infix. Q is often used as a data structure for computer simulation, where if there's a time events, you put the event in the queue and to be processed in the first in and first out manner. Then you can use a queue, right? So a computer simulation is a simulation on a single computer or network computers reproduce a behavior system. So for example, in the book, there is a hot potato game where this is a 6-person, for example, you have a 6 person, and each person passes the potato to the next person. And every n passes, like 5, you eliminate 1 person and the game goes on. So in this first round, Bill passed to David, to Suzanne, to Jane, to Ken, finally to Brad. Brad is eliminated. And then you have a smaller circle, then the game goes on. So it starts with Bill again, David, Suzanne, Jane, and Ken is getting eliminated. And then you have only 4 person until only 1 person left in the game. So that's the game. Now, how to simulate that, right? Now, details in the book, but so let's see. We can use a queue. We can use a queue to simulate the rotation. So at the end of time, the person in the front of queue is the one holding potatoes to begin the game. And when he passes to the next, you just simulate it by pop it off to the queue and immediately insert to the rear. So when I do that, David become in the front holding the potato, right? And Suzanne and Jane. Now, after a couple of rounds, it stops, and that like five person, it stops, and that person in the front is being eliminated, and the game goes on. Okay, So let's look at some code to implement this hot potato game. Okay, and so basically that algorithm is very simple. So let's say, just saying, in this case, I'm gonna import from collections, import deck, right? Like I said, I use deck to simulate the queue. So hot potato game. Let's say name list, like no, and how many people we're gonna skip for each round. All right. So simulation queue is a deck. Okay. And for each name in the name list, we're gonna do is to put them in the queue, right? In order. Not in queue. I think it's append. Wait. In queue is from the left, so append left. Okay, append left of name. So now I can print in queue to just verify. All right. And then after that, while sim queue size that is greater than 1, so there's more than one person in that queue. So we're gonna do a end round in queue and DQ, right? So sim queue dot, I think append left, right? That's in queue, append left of sim queue dot pop is from the right. So that's DQ and in queue. So for that, and after end rounds, the one that's on the top of the queue, that's still left, will be popped, right? Will be popped, and we don't enqueue it. Okay, so until there's only one person in the queue, we are just like simply return that person, right? Return that person. Okay, let's try it. Print hot potato, and we're gonna give them a list of Bill, David, Suzanne, and Jane, and Kent, and Brad. And I'm going for 7 person at a time. Let's run it. Oh, actually, I'm gonna have to. Oh yeah, that's man. What's going on here? So question deck the size. Oh, there's no option size. Okay, so would it be dot? Yeah. Oh, okay. Actually, we can just direct to length of key, right? All right, so that works. So Suzanne is one left in the game. Okay. Initially, we have Bill, David, Bill, Suzanne. So basically, in the for loop, we're gonna print this. We can just print it one time. We don't need to do that more. So Brad, Ken, Jane, Bill, right? 3, 4, 5, 6, and then you just top Bill send it to by. So it's like 1, 2, 3, 4, 5, 6. 7 is the Bill. Bill is eliminated, and then start again at the end. Suzanne is left. Okay. So this hot potato game is very interesting. Now that reminds me of a of a interesting story. Like I think at one point in a prison, there are n persons, and there is a um, a rule that the person so they form a line, and every odd numbered person, like from 1, 2, 3, 1 to n, right? And every odd numbered person will be taken away, and so you want to select a position where you are the only one left. So how you select that position, right? So every even number will be left, and odd number will be taken away. So what's the position you're gonna put stand? So that's a question for you to think about it. Or you can use Python to simulate that game. All right. So that's one example of the using Q. Now, in later when we talk about graphs and traversal and shortest path, Q is very important. We can use that to do what we call it breadth first search, where it will search all the neighbor nodes or neighbor paths until you search the further level, a level down, right? Until you reach the higher. So using that simple technique, using a queue, you can very easily search a shortest path between A and B. Okay, so that's a very short introduction. And of course, there's a printer simulation you can take a look at in the book. And we already talk about DEC. There's already implementation internally for Python. And the book also talk about checking a palindrome, which is a word that can be read from front and back. There's a lot of ways to implement a palindrome, right? Not necessarily using a queue. You can also use a stack, or you can use recursion. You can just simply using a list. So take a look and see if you can implement a function called check if the word is a palindrome. Okay, and that's it for the queue. And see you later. Bye.